So, there is a beautiful problem here on moment of inertia, but you will have to have a little bit of patience here because it is slightly complicated. So, let me read the problem for you first. Mi of a uniform disk about a diameter is I. Its mi about an axis perpendicular to its plane and passing through a point on its rim is to be found. See, you people must have remembered the moment of inertia of a disk as mr square by 2. But remember, there the axis that you will have taken will be by default the one passing through the center of the disk and perpendicular to the plane of the disk, right? Okay, but you do not know what is the moment of inertia of a disk about a diametrical axis. So, you will have to find it out first, and then only you can, I think, use the second part in order to solve the problem. So, what I will do is first apply perpendicular axis theorem in order to know what is his I. But let me brief you something about perpendicular axis theorem also. One strict warning about that theorem is perpendicular axis theorem has to be applied only for a plane lamina. It should never be applied for a body, and here you can consider this to be a thin disk. It is a uniform disk already given. You can also imagine the thickness of the disk to be negligible. So, it is a very thin disk. So, it is a plane lamina, and you can go ahead with your perpendicular axis theorem. Okay, what does it say? If you know the moment of inertia of a thin lamina about an axis, about two axes rather, which are perpendicular to each other and in the plane of the lamina. If you know the moment of inertia of a thin lamina, plane lamina, about two axes which are perpendicular to each other and in the plane of the lamina, then by adding those two, you get the moment of inertia about a third axis which is perpendicular to the plane of the lamina and passing through the point of intersection of those two. Fine. So, what I will do is, I will imagine the disk to be like this and the diametrical axis that he is mentioning to be these. See, these are the two axes and they are symmetrical. That is, the moment of inertia about this axis is say I1, the moment of inertia about this axis should also be I1. This is what I mean by symmetry. They are perpendicular to each other also, and now if I add these two, I will get the moment of inertia about a third axis which is perpendicular to the plane of the lamina, that is this one, and passing through the point of intersection. So, the two axes are going to intersect at the midpoint of the disk, and this is the axis I have taken which is perpendicular to the plane of the disk. So, I1 plus I1 is 2I1, and this you have already by hearted, it is mr square by 2. So, I will write 2I1 equal to mr square by 2, or I1 is mr square divided by 4, right. This is his I. The mi of a uniform disk about a diameter is I, and we have already found out the moment of inertia of a disk about any of the diameters, and we had called it as I1, but his I is our I1. So, I will write this as I. Fine. So, one thing is known. Now, what he is asking is again the moment of inertia about an axis perpendicular to its plane and passing through a point on its rim. This also we do not know. We will have to find it out, and the answer has to be expressed in terms of I. So, here you are supposed to use parallel axis theorem. So, let me remind you something about parallel axis theorem also. Parallel axis theorem can be very well applied for a solid body. You need not have to strictly apply it for a plane lamina like perpendicular axis theorem. You can go ahead even for a solid body also. And now, imagine the disk, right. What does parallel axis theorem say? Parallel axis theorem gives you the moment of inertia of this disk about an axis which is parallel to the one passing through the center of mass. Okay. So, if this is the disk and this is the center of mass of the disk, you can imagine the axis to be passing through the center of mass, and you already know this moment of inertia, it is mr square divided by 2, and you want to write about this axis. So, using parallel axis theorem, I will try to write it. See, this is the disk again, this is the center of mass. You know the moment of inertia about this axis which is mr square divided by 2, and now I want to write the moment of inertia about an axis passing through one point on its rim. You can read it here, through a point on its rim. So, I will shift the moment of inertia from this axis to this axis using parallel axis theorem. And what does it say? It is mr square divided by 2, which is the moment of inertia about this axis, plus mass into distance square, this distance. Between the two parallel axes that you are considering, that distance can be radius of the disk. So, mr square, and that makes it 3 mr square divided by 2, right? Mr square by 2 is the moment of inertia about an axis passing through the center of mass, and you want about this axis, so you have shifted using parallel axis theorem. So, Ig plus m into distance square. Distance fortunately happens to be the radius here. So, 3 mr square by 2. Now, this 3 mr square by 2 is what he wants, but none of the options are reading as 3 mr square by 2. You have to express the answer in terms of I. So, what I will do is, I will try to get the value of mr square from here. I is mr square by 4. So, mr square by 2 is 2I. Mr square by 2 is 2I. Therefore, 3 into 2I makes the answer 6I. See, mr square by 2 is 2I. So, instead of mr square by 2, if you substitute 2I here, the answer is going to be 6I. So, what is the answer? C is the correct answer. I hope you enjoyed this problem. It is slightly complicated, I had told you earlier. It involves, what is the beauty of this problem? Why did I take this? Because this involves parallel axis theorem as well as perpendicular axis theorem. Unless the student is aware of both the theorems, he cannot solve this problem.